All right, it is day 9 of distance learning, which means today we will be graphing linear equations that are presented to us in slope-intercept form. So a very quick reminder of slope-intercept form. Y equals mx plus b, where m represents the slope and b represents the y-intercept. Example before we fill in the note sheet, which I've attached to this Google assignment together. So a very quick an example, y equals 2/3 x minus 5. So we're going to do the opposite. Last time we took the information off the graph and plugged it into our equation. This time we're going to take the information from our equation and create a graph. The very first thing I need to do is decide which number represents my m, which number in this equation represents the slope. And the slope is always next to your x variable, which means the slope of this line is 2/3. My rise is 2, my run is 3, which means we're going up 2 units, over to the right 3 units. The second thing I need to determine is what is my y-intercept, and that is represented by your b value, which means at the end of this equation, the number without the coefficient, that would be your y-intercept. So we have our slope, how we're moving in our graph, and we have our y-intercept, where we're starting on our graph. That's at -5. So if I take a look at my coordinate plane, I am always going to start with my y-intercept. That's where my line is beginning. So I notice my y-intercept is -5. I start at 0. My y-axis is straight up and down, which means we are going down 5 units. 1, 2, 3, 4, 5. Here is where my y-intercept is. So 0, -5 is my y-intercept. And then in order to get to my next point, I'm going to be going up 2 units and to the right 3 units. So from my y-intercept, I'm going to be traveling up 2 units, 1, 2, and over to the right 3 units, 1, 2, 3. Now I can't stop there. The graph is going to extend all the way across my coordinate plane. So let's keep going following that pattern. Up 2, 1, 2, over to the right 3, 1, 2, 3. My rise and my run is not changing. Rise 2, run 3. And if you notice, I've run out of room. I go right back to my y-intercept and I'm going to follow it in the opposite direction. Instead of going up 2 units and over to the right 3, I can go backwards, which means I would be going down 2 units and over to the left 3 units. And if you notice, that point is still in line with the others. Let's continue. Going down 2 units and over to the right 3 units. And again, you can see I've run out of room. The last thing we're going to do is play connect the dots as best as possible, creating our nice straight linear function. So y equals 2/3 x minus 5, that equation is represented by this graph right here. The y-intercept is at -5 and the slope is up 2 and over to the right 3. All right, so at this point, if you have not done so already and you have access to a printer, you're going to print out your notes that were linked to this Google Classroom assignment. If you don't have access to a printer, then you can write down what I'm about to write down in your notebook. So just hit pause at any time on this video, but we're going to start filling in the blanks here on our graphing slope-intercept form notes. So y equals mx plus b is the equation that we've been using, and just to recall, m represents the slope and the b represents the y-intercept. So those are the two most important pieces of information that this equation gives us. The x and the y, those variables, represent our independent variable and our dependent variable. We've been calling our x our inputs and our y values our output. So we'll stick with that for now. But that is representing the point, the coordinate of the point that makes this equation true. So, how to graph a line that's given to you in slope-intercept form. The very first thing that you need to do is identify the slope and the y-intercept. So one says write down what the slope, which is m, is, and then write down what the y-intercept, which is b, is. And I just broke it. So again, you need to identify what m is and what b is. Then you're going to put a point at the y-intercept. So if you watched the beginning of this video, you saw me graph an equation very quickly. And the first thing I did after identifying what m and b was putting a point on our y-axis at the y-intercept. Once you've identified where your y-intercept is, you're going to start counting from the y-intercept. You're going to count up if the numerator of the slope is positive, and then count right the number of the denominator, which is your bottom of your fraction. So again, from the y-intercept, you're going to count up if the numerator of the slope is positive, and then you're always going to count right the number of the denominator. Or you're going to have to count down if the numerator of the slope is negative. And then count right the number of the denominator. So again, two things you should note. The sign of the slope, positive or negative, decides whether you're counting up or down. But the denominator is always telling you how many units across. When I say across, I'm saying moving to the right. You're going to continue this pattern until you're out of room on your graph, just like we did on that first example. And then once you run out of room in the right direction, you're going to go back to the y-intercept and move backwards. So we're going to do two examples together. They're on the bottom of your notes. Zoom in a little bit. So we're going to graph these two examples. And so the first thing I need to do, again, I know I can't see the notes up here, but you should have them written down, is write down what the slope m is and what b is. So I'm going to use blue for m, which is my slope, and green for my y-intercepts. So when I go to look at my equation written in slope-intercept form, 4/3 is what's in my m spot if my equation was y is equal to mx plus b. So since m is right next to x, my slope of my line is going to be 4/3. My b value would be this whole thing. And notice I highlighted over that minus sign because that b is actually equal to -2. So I know what m is and I know what b is. So step number 2 that we just filled in says to put a point at the y-intercept. So we are going to put a point at the y-intercept, and so we have to look at what b is. It's -2. I'm going to go to my y-axis, which is my vertical axis, and put a point down here at -2, since that is what my y-intercept is. Step 3 in my notes says, from the y-intercept, count up if the numerator of the slope is positive, or count down if the numerator of the slope is negative. When I look at my slope, it is a positive slope. That means from my -2, I'm going to be counting up 4 units, 1, 2, 3, 4, and then over to the right 3 units, 1, 2, 3. And that spot right here is where my second point exists. That's the second point on my line. And again, I have to continue this until I reach the end of the graph. I haven't reached the end of the graph yet, or the coordinate plane, so I'm going to keep going. My rise again would be 4, so up 1, 2, 3, 4. And then I'm going to be going over to the right, 1, 2, 3. There's my third point on my line. If I tried to go up 4 again, I'd run out of coordinate plane space. So that means I have to go back to my y-intercept and reverse what I've just done. So going back to my y-intercept brings me back to this point at -2, but now I'm going to move in the opposite direction. If this was up 4 and right 3, let's put a little note here, this was up and this was to the right. Then the opposite means I have to go down 4 and left 3. So down 4, 1, 2, 3, 4. And this time we're going to move left 3, 1, 2, 3. And you'll know you did this right because the point that you plot should still be in line with the other points you have on your graph. Your last step is to play connect the dots, and you can see the graph of the line y equals 4 over 3x minus 2 right here in pink. We're going to take care of this second example together as well. We're going to go through the exact same process. So we are going to first identify what m is. And so I'm going to use my highlighter. Notice I'm highlighting the sign in front of that number. And m is going to be my slope. And then I'm going to highlight my y-intercept, including the sign in front of it. So let's fill in the information that we were given. The slope of the line that we have here is negative 1 over 2. Notice I wrote the negative with the top of my fraction. That's going to go in with our numerator there. And our b value is a positive 3, which means I can just put a 3 there. We don't have to put a plus in front of it because positive numbers, you don't have to put the sign. And then we're going to decide before we even start graphing what this slope means. So the negative 1 and the positive 2 tell you two different directions. The numerator of your fraction, the rise, is going to tell you whether it's going up or down. Because this is a negative 1, this is going to represent going down 1 unit. And since this is a positive 2, we are still going to be moving to the right 2 units. So now we're going to create our graph. We are going to start at the y-intercept, which is here in green, which means our y-intercept is at a positive 3. So again, here's my y-axis, here's my x-axis. On my y-axis, I'm going to plot the point 0, 3. And then I'm going to follow my slope. Negative 1 tells me to go down 1 unit, and 2 is telling me to go to the right 2 units. And I can plot my point here. I'm going to continue that slope, continue that pattern. Down 1, right 2. Down 1, right 2. Down 1, but if I go right 2, I end up off my coordinate plane, which means I have to go back to my y-intercept and continue that pattern in the reverse direction. So this time I'm going to go up 1 and left 2. And a quick check, my point is still in line with the others, so I've done it correctly. So up 1, left 2. Up 1, left 2 until I run out of room. Then I'm going to play connect the dots. And you'll know you did this right if all of your points end up in a straight line. So, just to reiterate, you're going to start with your y-intercept and then use your slope as the directions of how to get to the next point. What to do if your slope is a whole number. So if you were given the equation y equals 3x minus 2, the 3 is still your slope, but remember our slope is telling us the rise and the run. The good news for us is that 3 as a whole number can actually be written as the fraction 3 over 1. And so what that means for me is I'm still going up 3 units, but I'm moving to the right 1 unit. So whenever you see a whole number, you can write it as a fraction by putting that whole number over 1. The same thing would be true if I made that the integer negative 3. If that were a negative 3 slope, you would just write this as negative 3 over 1, which just changes the direction. We would then be going down 3 and to the right 1 still. What if there's no number next to the x? So if you have the equation y is equal to x minus 5, then you need to remember what happens if you have a variable with no coefficient that you can see. Don't forget that coefficient is just 1. And the slope of 1 can be written as 1 over 1. And so if you don't have a y-intercept that's shown, it might look something like y is equal to 3 halves x. If you notice, our slope is given to us right here, so that's our m value, 3 over 2. But our y-intercept is not shown. That's like having a plus 0. So the y-intercept of this line right here would be at 0, which is the point 0, 0,